day, my students. I welcome you to Eko Learners Support for WAEC and NECO candidates. My name is Joseph, a chemistry instructor. I want you to sit back and let us enjoy ourselves together as we take you along solubility.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Solubility. Can you say that? Solubility. That is wonderful. So before I go into the topic properly, you will need to understand that there are some knowledge you must have acquired before you can have a better understanding of solubility. And the knowledge is solution. You remember in our last class where we talked about solution. So solution basically means solutes and what? Solvents. So the solute is the major words, major ingredient. I call it ingredients, major component that you need when you are forming what? A solution. So look at this. These are different words, solutes, salt, with different colors. So we have the salt of what? Sulfate, which could be in form of white, blue, as you can see. Then we have salt of what? Sodium decahydrate, which could be in form of what? Crystals. Now, what would be our learning objective? So at the end of the class, you will be able to, one, define what we call solubility, mention types of saturated solution, calculate solubility problem. This is what we are going to be talking about as we progress in this class. Fine. So good. When you look at the board, you see what? Two solutions of the same concentration in this particular case. But what do you notice about the volume? Yes. This is twice. So what do you notice about the what? The amount of solute in the solution as well. You discover that this is 2. Why what happened here? Yes, this is what? 4. What's the implication? The implication is Y also is twice as much as that in the solution what? X. So the solute here is what? 4. The solute here is what? 2. The solvent here is what? Yes. The solvent here is 2. Why the solvent here is what? 1. Just like you are double the solution. So in this case, the concentration still remain the same. Now, when you look at what you have on the board as well, you have the solutes. Yeah, these are solutes. And you have the what? The solvents. Yes, molecules. So with this, you already have what we call what? A solution. But when you have the maximum amount of solutes that you can dissolve in this particular solvent at that particular what? Temperature, we talk about solubility. So on this note, a solubility of a what? Of a solute in a what? In a solvent at a particular what? Temperature is the maximum amount of what? Solutes. Maximum amount of solutes in moles or in gram that you can dissolve in 1 dm cube. And some textbook may put it in 100 gram or in 1000 gram of solvent at that particular what? Temperature. That's what we call solubility. So when you're talking about solubility, we're talking about maximum amount of solutes that you can dissolve in 1 dm cube of what? Solvent at that particular temperature. So at home, you can practice it. You can just mention 100 centimeter cube of water in a cup and begin to add what? Solute, which is salt, and begin to see what happens to this particular water when the salt is being added. Discover that the salt get dissolving as you are pouring inside the water. But remember, maximum amount. To get to a point that the solute will not be able to dissolve in that water called solvent. You have already reached what we call saturation. So this maximum amount of solute that you can dissolve in 1 dm cube of solvents at that particular temperature is what we call solubility. Okay, fine. Now, what do we call unsaturated solution and what saturated solution? Remember as well that we have super saturated solution. Now, basically, when you say unsaturated solution, look at this particular solution. Look at this particular solution. This is solute. So what happened? I'm adding what? Water to the what? To the solute. Inside what we call a volumetry what? Flask. So this volumetry flask is calibrated here. So let's say it's 1,000 centimeter cube that you can take. Now you begin to add what? Water to the solutes and continue to what? Dissolving it. It will get to a point that it gets dissolved and form this particular solution C. At that particular point, we say you form what? A solution. It's now of two types. You can say a saturated solution. You can say what? Unsaturated solution. So basically, what do we mean by saturated solution? Yeah, it's a solution which contains less of the solutes that it can dissolve at that particular temperature. What does it mean? It means the solution, the water, can still take what? More solutes. But peradventure, you don't have what? More solute to add to that particular solution. So we call it unsaturated solution. But in a case where you have more solute with you, you have excess salt with you, and you've already measured the water to be 1,000 centimeter cube, and you keep adding this excess salt inside the water, it will get to a particular point where the solute, which is the salt, will not be able to dissolve again in the water. Rather, begin to form what we call undissolved particles. At that point, the solution is telling you that it has already reached what we call saturation. So that is called saturated solution. So a saturated solution at a particular what? Temperature is the one which contains as much what? Solute as it can dissolve at that particular what? Temperature in the presence of what? Undissolved, yes. In the presence of what? Undissolved solute particles. That is very, very essential for you to be able to identify or to know that that solution has reached its saturation. There must be a presence of what? Undissolved solute particles. Fine. So, can we move on? So let's move on. Yes, I want you to watch this video. It's about what? Solubility. Now, when you look at what I have on the screen, what happened here? The solution can still take what? More solutes. As I've rightly said before, so we call it unsaturated solution. But in this particular case, what do you notice? There's a presence of what? Undissolved particles. Look at it. To tell you that that solution can no longer take what? More solutes at that particular temperature. So we target saturated solution. It can no longer take more solutes. Fine. Now, when you look at the board again, you notice that the concentration in mole per dm cube of a saturated solution is termed the solubility of the what? Of the substance. That is, solubility in mole per dm cube is equal to the concentration of that particular solute in gram per dm cube divided by what? Molar mass. So it's essential for you to note that. So in case you are asked to calculate the solubility of a given what? Salt at a particular temperature. So this formula can be of help to you. Also, note that the mole is equal to molarity times volume divided by what? 1000. When the volume is given in centimeter cube. Okay, fine. Also know that mole is mass over what? Molar mass. So in case of having mole can be replaced by mass over what? Molar mass. And that will equal to what? Molarity times volume divided by what? 1000. So in this case, molarity can be your what? Solubility. Because I told you earlier that the molarity is times solubility in mole per dm cube. Fine. So what can you see on the screen? Do you notice one thing? Yeah, you need to notice it. So this is a Bunsen burner and this is heat applied. So you have a solution in the beaker. So what happened to the solution in the beaker? The water in the solution is getting what? Evaporated. So it's losing the water to form what we call what? And retaining the salt, which is the what? The solute. So this solute could mean what? Residue. Note that. When all the water has been evaporated, what you will notice? Yeah, you notice the salt being recovered. And this salt being recovered, we call it a residue. And we can calculate the amount of salt that remain after evaporation might have taken place with the help of what? Heating. And that will take us to the next slide. Yes, to support our point about the effect of what? Temperature on the what? On solution. So I've told you earlier that as temperature increases, the solubility increases. So when you look at these two solutions, this hot what? Water. So this cold water. Now when the solute is being added, so the solute here is the T. When it's being added, which one do you think will dissolve faster? Yes. I hope you can tell me. Yeah, I hear some people telling me that the one with cold. No, you could be right. But in this case, you are wrong. You remember your what? Your rate of chemical reaction. That this will what? Because the temperature here is high, the solubility will be more faster. So this will dissolve faster than when it is what? Cold. That is one of the effects of what? Now, the activity we have to do together in the class. So we need to understand, yes, how the solubility equation look like and how you can go about it. Remember that when you're talking about solubility, we are talking about maximum amount of what? Solutes that you can dissolve in 1 dm cube of what? Yes, 1 dm cube of solvent at that particular temperature. Well done. So based on the questions on equilibrium, as you can see on the board, in an experiment to determine the solubility of KNO3 in water, the following results were obtained. The first one is the mass of the what? Evaporating dish. So let's call this mass 20 gram. So let's call it what? 20 gram. Then the mass of evaporating dish and what? Saturated solution. So in this particular case, they are telling me that dish plus saturated solution is equal to what? 37. What is the implication? The implication here is I have the dish plus solutes plus solvents giving me what? 37 grams. Good. Mass of evaporating dish and salt, which is the what? The residue, is 20 grams. 27 grams. So what's the implication? The implication is I have the dish, so I have the solutes, and we're told that it's 27 grams at that particular what? Temperature. So the temperature here is 40 degrees Celsius. So the question is, we have to calculate the solubility of KNO3 at this particular temperature. What do we need to do? Firstly, we need to get the mass of solutes. That is the first thing we need to get. Second one, we need to get the mass of solvents. Then, thirdly, we need to remember that the concentration, which is the solubility now, the concentration in mole per dm cube of that particular salt is equal to concentration of that salt in gram per dm cube over molar mass. Yes. Now, how do we go about this? Let's move to the next one. Slide. Now, let's move to the next slide. So in this next slide, the mass of solutes is equal to what? Is equal to the dish plus solutes minus mass of dish. And that will give you 27 minus 20, which is 7 grams. And that's what you have here. Now, to get the mass of what? Solvent. That will be dish plus saturated solution. Dish plus saturated what? Solution. Dish plus saturated solution. Dish plus saturated solution is giving us 37 grams. The mass of water will equal to 37 minus 27, and that is giving us 10 grams. So how do we get that? You remember that we are giving the mass of dish plus saturated solution, and the saturated solution contains both the solvents and the solutes. So if you are to get the what? The solvent, you will say 37 minus what? 27. And that will give you what? 10 gram. Now we'll be able to calculate the mass of solutes and the mass of solvent. So the next step will be, if 7 grams of solutes is equal to 10 grams of solvents, we are looking for the maximum amount of what? Solutes in gram now that will dissolve in 1000 grams of solvents. And when you cross multiply, what you are going to have is x times 10 is equal to 7 times 1000. So divide both sides by what? 10. So x will be equal to 700 grams per dm cube. This is the mass of solutes that actually dissolve in 1000 centimeter cube of solvent. If that has been settled, then come down here and say solubility of what? The salt is equal to what? Mass concentration divided by what? Molar mass. And they've given us the molar mass of the salt to be what? 101. Therefore, you have 700 divided by what? 101. And that will give us 6.93 mole per dm cube. Alternatively, we can go with this. Mole equals to what? Mass over molar mass. And also 700 grams of KNO3 saturated or saturates rather 1 dm cube of what? Water. Therefore, 700 divided by what? 101 will give you what? 6.93 mole per dm cube, which simply means 6.93 grams of moles, no, 6.93 moles of KNO3 saturate 1 dm cube of solvent at that particular temperature. On that note, we take us to the next slide. So what do I have here? I want to appreciate you for listening. In case you have any questions, comments, or any suggestion, you can reach out to us. Thank you for listening, and bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.